Hi all, welcome back to one more session. So in today's video we are going to talk about entire APB protocol in one go. I have already made videos on this APB protocol in detail, like part wise I have made a video on this APB protocol. But in today's session we are going to talk about entire APB protocol in one go. Mostly it is used as a reference for you if you are going for any interviews or else anything. Okay, so instead of learning it bit by bit, if you see this video entirely, it may be for either 50 minutes or 1 hour. Okay, if you see this video, it may be useful for you when you are entering into any interviews or else any internship exams or else like that. Okay, so let's not waste any more time. And before going into this video, if you are new to this channel, consider subscribing the channel and hit on the notification bell also. And also please do like this video if you like my explanation, because it is kind of motivation for me in order to make more such videos on design and verification course, right? So coming to APB, as you all know that APB is the part of AMBA family protocols. So as I told you, what is the reason behind telling the part of AMBA protocols means in AMBA protocols you will be having many kinds of such protocols like APB, AHB, AXI, etc. So AMBA is Advanced Microcontroller Bus Architecture. Basically, okay, the main reason behind introducing this APB protocol is that in order to provide simple and efficient way in order to interconnect low speed peripheral devices. So basically, in order to communicate the low speed peripheral devices to the high speed devices like processors and all, okay, we will be using this APB protocol. Okay, in this APB protocol, we are going to learn these topics like how the AMBA, like introduction to AMBA, just we have done it, like AMBA evolution, and that means how the versions, what are the versions that were introduced based on the versions and all, we'll be discussing it, and then AMBA architecture, and then we will be introducing the APB protocol, and within the APB protocol, what are the three important topics that you are going to learn is that signal descriptions, and then the state machines, and then the timing diagram. So these three are important. Like since you will learn about when while you are learning about signal descriptions, you will be learning about this master slave communication also, and then state machine, nothing but you all already know that APB is the real-time application of the finite state machines. Okay, I have already explained about the finite state machines also. If you didn't see that video, I'll link that in the description box. You can go there and check it out. And then timing diagrams. Okay, based on the transfer, we will be checking this timing diagrams. So these are the things we are going to discuss today. Right now, as I told you, it is the part of AMBA architecture. So, AMBA architecture is nothing but it's a set of interconnect protocols. Basically, we are having two kinds of protocols, which are communication protocols and interconnect protocols. So, AMBA architecture is nothing but it consists of set of interconnect protocols like APB, AHB, ASB, AXI. So, all these are interconnect protocols. So, APB is the interconnect protocol. Why? Because we are connecting it, we are using it to connect. Okay, we are using it to connect various peripheral devices. That is why it is an interconnect protocol. Okay, now coming to the AMBA evolution. So this is how the various versions were introduced in AMBA protocols like APB, AHB, AXA. So all these were introduced bit by bit. So, and when coming to the APB here, APB and APB2 versions, if you see here, these two are same, because there is no much revision made between this APB and APB2 versions. Okay, and then coming to APB version 1.0, this is the mostly used and mostly read APB protocol or specifications. Okay, when you download it from this because APB is the what we can say, this is the uh, so APB is the open source. So if anyone want to download it, you can download it by using this in the ARM website. So mostly when you download it from the ARM website, you will be seeing this AMBA version 1.0. Okay, so what is the changes that has made from AMBA APB 2 to APB version 1.0 is that two signals were added in this AMBA V 1.0, and then in the AMBA version 2.0 another two signals were added. Actually the APB is having 8 signals in total, so in the revised version of version 1.0 there were 10 signals. Okay, and then in the revised version from V 1.0 to V 2.0 another two signals, so total of 12 signals were there in version 2.0. Okay, so we will be seeing while we are discussing about details what were the versions that were added between AMBA version 1.0 and AMBA version 2.0. Okay, so this is the evolution of AMBA architecture. Now coming to the AMBA bus architecture, if you see here, this is how the interconnection, as I told you, all the AMBA set of protocols are interconnect protocols. So here, what is happening actually in the architecture, if we see it, if we take a real-time use of this APB and AHP or AXI protocols, so how are we going to use them? If you see this architecture, you can understand here. So basically, for any device, the processor is the heart, is it or not? So whatever whatever when you want send some data into the transfer, when you want to send some data into the processor, or when you want to read something from the processor, okay, you should have connection to that. So basically, if you see here, all the high bandwidth components like RAM, memory interface, DMA bus master. So all these are high performance components. High performance components means they will be having higher bandwidth, okay, higher frequency rate. So because all these are high bandwidth and high performance process, these need a bus which will be used for high performance. Is it or not? So you can't use APB here. You will be using AHP, or mostly you will be going for AXI, because later AXI was introduced. Firstly, AHP or ASB were introduced, so that is why we are taking it as AHP or ASB. Mostly we will go for AXI nowadays. So we will be using these buses like AHP, ASB or AXI buses in order to interconnect these high bandwidth protocols. Sorry, high bandwidth components. Okay, now, along with this high bandwidth components, there are also some low bandwidth components. Okay, like for example, you will be connecting keyboard or programmable interface input output devices like mouse, or some pen drive, or some UART, some timers. So all these are low peripheral devices, low speed peripheral devices. Why? Because they consist of low bandwidth and low frequency. That is why they are low speed devices. So in order to connect these low speed devices, we don't need high bandwidth devices. Okay, so that is why APB was introduced in order to connect these low speed devices, right? So we are connecting all these devices through APB. Now we are connecting these all high bandwidth devices to AHP. Now what happens? Now there should be something which will be converting this high speed data to low speed data, and low speed data to high speed data, because low bandwidth data can't be assigned to the high processor devices. Similarly, high bandwidth data can't be assigned to the low bandwidth devices. So that is why there should be some bridge which will be converting this high speed bandwidth devices or high frequency to low frequency, and low frequency to high frequency. So in that case we'll be using the bridge here. Okay, so basically, okay, as we in the introduction I have told, like master slave communication. So master means something which will be sending you the data, and slave means which is receiving the data. Is it or not? So basically, when we are taking this particular high performance devices into consideration, then for example, if you are taking this processor as the master, if you are taking this processor as the master, then bridge will be slave. Okay, because bridge is receiving something from the master. Okay, now if you are taking some PIO or keypad into consideration, then bridge is going to be its master, because bridge is giving the instructions to this keypad. So that is why if you are taking the high performance devices, then bridge is the slave. And if you are taking the low performance devices like keypad, timer, okay, bridge is its master. And these are the devices which are the slaves of this particular thing. So This is how the AMBA architecture, like this is how you will be using this APB HPXI bus protocol buses. Okay, so this is about the AMBA bus architecture. So now coming to APB protocol. So as you all know that APB protocol is a part of AMBA family. So as I told you, it is used to interconnect the low peripheral devices, which is why it is a low cost interface. And here the most important thing in APB is it is very simple. Why? Because it is not a pipeline structure. Okay, since it is not a pipeline structure, it is very simple structure, and every transfer in the APB takes at least two clock cycles. That means when you want to transfer the data through APB bus protocol, it will be taking two clock cycles in order to transfer your data. It can't be done in one single clock cycle. Why? We'll be talking it in the next phases. Okay, why it need two clock cycles, we'll be talking that. But as for now, just remember that every transfer when you are doing it through APB bus, then it takes two clock cycles. Okay, so all the transitions, that means every transaction or every transfer that you are going to do through the APB bus protocol, APB bus, it will be doing only in the positive edge of the clock cycle itself. Okay, so in APB, the positive edge of clock cycle and the reset should be active low. So these are the two considerations that you should consider. Okay, so this is about the APB protocols. Now coming to the APB signals. Okay, so these are the signals that we will be seeing in the APB, right? If you see here, how many signals? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, total of 10 signals, right? So this is APB version 1.0 structure. Okay, right? So else if you see here, these are the various signals. So among this, so along with these two signals, okay, sorry, this is APB version 2.0, because here you there are another two signals which were clock and reset. Okay, these were not included in this because they are already input signals, so that is why they are not included, the clock and reset signal. Okay, so this is version 2.0, right? So let us see what were the signals that were introduced in APB, what that were previously there in EPB, and then within version 1.0, what are the signals that were introduced, and within version 2.0, what are the signals introduced. Okay, before going into the signals, like this is how the thing takes place here. See, these are the slaves, or these are the low peripheral devices. So these low peripheral devices are connected to the APB to AXI to APB bridge. So basically, this is our APB protocol, APB bus. Okay, through this APB bus, it is connected to the AXI to APB bridge. Okay, from and again, this bridge is connected to our high speed protocol, like high speed bus. Okay, this is our low speed bus, which is APB, and this is our high speed bus, which may be AXI or AHB or anything. Okay, and this is our processor. Okay, this is how the connection, just like we have seen this in this particular architecture, the same thing is going to run here, but here I'm just taking only the processor. So this is my master and this is my slave. If I'm taking this particular thing as my if we are talking about AXI, okay, and then if we are talking about APB protocol, then this is my master and this is my slave. Any of these components or all these components also, because one master can have any number of slaves, right? So this is about the signals. Now if you see here, okay, so the first thing is clock and reset. As I already told you, the clock should be of positive edge and the reset should be of active low in order for the transfer to takes place. Active low, okay, and then positive edge. Now coming to the signal. So if you see here, some signals were going from master to slave. If you see here, these are the signals that are going from master to slave, and there are some signals which are coming from slave to master. Now, the signals which are going from master to slave are considered as output signals. Okay, the signals which are coming from slave to master, they are considered as input signals. Okay, while you are writing the code, these are the things that you should consider. Okay, so these all signals are outputs and these signals are inputs, right? Now coming to the signal individually, let us discuss about the signal. So first thing is p select. As before, just before I have told you, a master can have any number of slaves, right? So similarly, if you are having only one slave, then p select will be only one. For example, if you are having some, if you see here, there are having four components. If you are connecting four components, then there will be four slaves. Okay, so based on here, basically you will be if there is only one slave, then it will be p select. Okay, if there are many number of slaves, then there will be p select x. X represents how many number of slaves. For example, if you are taking it as p select x, then the notation will be p select 1, p select 2, p select 3, p select 4. That means total 4 number of slaves. So the p select 1, if the p select 1 is high, then the first slave is selected. If p select 2 is high, then the second slave is selected. Okay, so similarly, if p select 3 is high, then the third slave is selected. If p select 4 is high, the fourth slave is selected. In this way, based on if there are many number of slaves, based on which slave is high, that particular slave is selected. If there is no here, if you see in this only one slave, so if p select equal to 1, then that means the slave is selected. If p select equal to 0, that means no slave is selected. Okay, so this is how the signal. So selection of the signal is considered by using this p select. Okay, PCEL. And here if you see the signals, one interesting part, everything is started with p, because since this is the APB bus, we will be using the p as the first notation. Okay, when you are going for AHB, you will be using as H select, H enable, like that. Okay, so that is about the p select. Now coming to the next thing, which is p enable. Okay, coming to the p enable, okay, p select means the slave is selected. For example, I have selected this particular I2C. Okay, now after selecting the slave, the master have to transfer the data to the slave, is it or not? So in order to transfer the data, the slave should be ready to accept it, is it or not? That means the master should give some instruction before giving it the transfer to it, that I am going to send some data to you. Okay, that means the master should give instruction to the slave that it is going to send the data. So that is done by this p enable. If p enable equal to 0 means slave is not ready to accept anything. Okay, so p enable equal to 0 means that master is not going to send anything and slave is not going to accept anything. If p enable equal to 1, then that means the data transfer is going to take place. That is just like instruction. Okay, that is given by master to slave, that I am going to send something to you. So you get ready. So in this way, it is giving some instruction. Okay, so that is p enable, right? So after giving the instruction, like if p after p enable equal to 1, so the slave is selected. So as soon as the slave is selected, for example, if you see here, there are four components here. So for this four components, every component will be having its registered address, is it or not? Okay, so that address will be for p address. Okay, address is nothing but every component will be having its individual address. So based on that, for example, if you have selected this second slave, then this particular address will be registered. Okay, so based on p select text, the address will be registered. Registered means the address will be allocated. Okay, the memory will be allocated for that particular address, for that particular component. So, and in the APB, this p address is of 32-bit wide. Okay, now if you see here, only the width mentioned signals are having their width. Okay, if you see here, p for p select and p enable, I didn't, and also for p read, I didn't mention any width. From that you should understand that they are of single bit wide. That means they are scalar quantities and it is of single bit wide. And for the mentioned width signals, they are having that particular mentioned width. So in this, p address is of 32-bit wide. Okay, so based on this 32-bit wide only, you should select the slaves. That means if you are selecting some 3 or 4 slaves, and if their address range is exceeding this 32-bit, then the APB is not going to take that into consideration. Okay, you should keep that in your mind while you are selecting the slaves. You should select the slaves according to the address range of that particular APB bus. Okay, so APB bus 32-bit wide. So this is about the meaning of address. Now coming to P right. Now for any transfer, okay, from master to slave or slave to master, when it comes to transferring data, it is of two types, like read and write. Is it or not? So reading means nothing but whenever you are uh, whenever you want to transfer, whenever the master want to read something from the slave, then the read transfer takes place. Okay, whenever the master want to write something into the slave, then the write transfer takes place. Okay, so based on the p write signal, okay, this read and write transfer is going to happen, because you already know that no at a time no two type of transfers can't takes place. That means at a time we can't read and write, right? First we should read and then we should write, or either first you should write and then read. You can't do same two things at the same time. So similarly here, based on the p write signal, that means if p write equal to 1, then that means write transfer is going to happen. If p write equal to 0, then read transfer is going to happen. So this is how, based on the p write signal, this read and write operations are going to happen. And this is also single bit signal. Now coming to, okay, p write is 1, that means you can write the operation. So writing the operation means you will be writing the data. Okay, from master, for example, you are sending some data like this. Okay, you want to send this packet of data into the APB slave. Okay, so when you want to write something into the slave, this is my data, so this is my PW data. Okay, so I want to write this data into the slave, right? So that is PW data. Okay, here PW data will be done only when P write is 1. Okay, if P write is 1 only, then you can send PW data. If p write is 0, then you can go for pr data, which is p read data. Okay, so this is about the p write and pw data. Now since we are talking about pw, let us talk about p read also. So if you see here, p write is output, because master will be writing something into the slave, so that is why it is going from master to slave. Now if you see the p read data, why it is in this direction? Because master is going to read something from the slave. That means the data is in slave, and this is going to be read by the master. So that is why it is in this direction. Okay, PR data means reading something from the slave. P write data means writing something into the slave. Okay, get to know this difference, right? So this is about the period data, and period data and period data also 32-bit wide, because p address is 32-bit wide, so obviously p write and period will also be 32-bit wide. Okay, and then coming to the let us see first these two signals before these two signals. So p ready, p slave. So until now what signals that we have discussed, like clock, reset, p select, p enable, p address, p write data and period data. So these are the common signals which are there in APB as well as APB2. Okay, now in APB version 1.0, these are the two signals that were introduced. Okay, p ready, p slave error. Basically these are kind of response signals. Okay, that means the slave is responding to what the master is sending. Okay, that is why these are response signals. So these two were introduced in version 1.0. P ready, p slave error. Okay, p ready means, okay, this transaction, this everything is being done. Okay, when this is going to be done, that means how, when you want to write data or when you want to read data, the slave should be ready to write or read. Is it or not? In the slave should be ready to take the transfer, or the slave should be ready to give the transfer. So that thing. That means the slave is responding whether it is ready or not to the master by using this p ready signal. Okay, so when you are seeing in timing diagrams also, you will understand that. Okay, whenever this p ready is 1 only, then only the write or read data takes place. Okay, if p ready is not equal to 1, then the master have to wait for the slave to get ready. Until then, the write data transfer or read data transfer won't be happening. Okay, okay, everything is ready, like you are having the data, everything is fine, and you can read the data and write the data. But for that transfer to happen, this ready should be equal to 1. That means slave should be ready to accept the data or read the data and write the data. Okay, so that is why p ready equal to 1. Okay, now after reading, after ready is equal to 1. Okay, that means that master have sent the data to the slave, right? Or the master have read the data from the, everything is done. So during this transfer, that means through APB protocol, APB bus only, you're transferring the data. Okay, during this transfer only, the data will be reaching from master to slave. So during this transfer, if there is any loss of data, due to various reasons, you'll be having this loss of data, of course. So if there is any loss of data, then the slave will be responding to the master through this p slave error signal. That means if p slave error equal to 1, then this indicates there is error in your transfer. Okay, if p slave error is 0 means then there is no error, everything is fine. But if p slave error is 1, here SLV ERR means slave error. That means slave is telling that there is some error in your transfer, there is some error in your data transfer, you should just check that out. Okay, that is the work of p slave error. So these two were introduced in version 1.0. Now coming to the later versions, which are strobe and protect. Okay, p strobe and then p protect. Okay, for example, if my data is of 32-bit wide, okay, and also you should remember one thing: if this strobe signal is only for p write data but not for p read data. Strobe is of 4-bit wide. So in this 4-bit, what will be happening means your 32 bits is divided into 4-bit wide. Okay, so from 0 to 8, it is considered as strobe 1. Okay, that is, this is strobe of 0. That means it is of 8 bits. Strobe of 1, which is of 16 bits. Strobe of 2, which is of 24 bits. Strobe of 3, which is of 32 bits. That means if the strobe is of 2, then that means you are using only 24 bits. Okay, similarly, if the strobe is of 1, strobe 1, that means you are using only 16 bits of data. That means you need to transfer only 16 bits of data. So based on this, you will be using the strobe signal. And then coming to the protection signal. So basically, you will be transferring the data. Right, you will be transferring the data from one component to another component, and also you'll be transferring it to the high bandwidth devices. And meanwhile, there will be bridge which is used to convert the high frequency to low frequency to high frequency, and all. Right. So during this transfer from one component to another component, there should be some protection, which is why we will be using this P protect signal. And if you see here, these two are the signals that were introduced in version 2.0. Okay, APB version 2.0, these two signals were introduced, P strobe and P protect. Okay, P strobe is of 4-bit wide and P protect is of 3-bit wide. Right, I have explained in detail about this strobe and protection in my APB class, signals class. I'll link that also in the description box. You can go there and check it out. So these are the writings of that. I'll just pause this so that you can just pause this video, and you can read it, and if you are having any doubts, you can comment me in the ping box. Okay, so this is the P strobe and P protection. Right, now coming to the operating states. So as in the starting, I have told you that every transfer in APB takes 2 cycles, like 2 clock cycles. So what are these 2 clock cycles? One is setup, another is access, clock cycle. So what is the setup and access clock cycle is basically, so as we already know that it is just a kind of finite state machine. So the transfer will be, we'll be seeing how the transfer is going to take place. So the first state is ideal state. So from the name itself you could say there is no, everything will be, all the signals will be in the zero state. Okay, there or in their default value state in the ideal state. So if there is no transfer, then that means you should remember that the APB bus is in ideal state. Okay, now if the transfer takes place, okay, now if the transfer is going to take place, it is taking two clock cycles. That is, one is setup, another is access. So in the setup, what happens? Okay, so it will be taking partly. You can say that like entire thing will be going, won't be going in one go itself. It will be divided into two parts. So first part is setup phase and the second part is access phase. Okay, so in the setup phase, what happens? It will be selecting the slave. Okay, so for example, this is my master and this is my slave. Okay, first the master will be selecting the slave. Okay, that means as I already told you previously, if p select equal to 1 only, then only the slave selection is happening. Here if select is 0, that means no slave is selected. Now first I am selecting the slave. Since I have selected the slave, along with slave there are other signals which will be activated here. Since the slave selection is over, so the address will be created. Similarly, since slave selection is over, then the p write will also be activated. So since selection of slave is done, so next what will be happening? Either you will be reading something or writing something. So the p write signal will also be activated to either write is 1 or 0. Okay, so these two signals will be uh, activated along with p select equal to 1, and here the p enable is 0. That means slave is selected and all these are getting readied, but the master didn't send anything to the slave that I'm going to. Okay, I have selected the slave, but it takes some time in order to transfer the data. So that time is access. Okay, that means here this will be happening in one clock cycle, and in the second clock cycle, what happens? The access phase is going to happen. So in this access phase, what is happening here? P select equal to 1, which is already in the setup phase, and then P enable is 1. That means in the access state, the master is telling the slave that I am going to send you data. Okay, now after this access phase, okay, sorry, not after, within the access phase only, okay, the master have sent the signal to the slave that I am going to send you some data. Now slave should also respond, is it or not? The slave will be responding through p ready signal. What it will respond? If the slave responds, okay, I am ready, that means I am ready to transfer, I am ready to take the data, then the transfer happens. And then if there is another transfer, for example, transfer is nothing but we'll be transferring some set of data, is it or not? If there are some three packets of data that I want to transfer, okay, this data is transferred, fine, because period is 1, so the transfer took place. But there are two more packets of data that I need to send. So again it will go to setup. Again, it will, the select will be 1, and again the process p enable will be equal to 0. Again coming to pay access state, and again this transfer is happening. If period equal to 1, again it will be going. So in this way the cycle will be continuing. Okay, for instance, okay, if after sending that, I am going to send you data by the master through p enable signal, if the slave responds that I am not ready, that means if p ready equal to 0, then what happens? Nothing. The master should wait, is it or not? Because it should send data, but the receiver is telling that I'm not ready for receiving the data. Then until the slave is ready, the master have to wait. So that is the wait period. So what will the master do in during this wait period? Nothing. It will just stay in the access state until the period is 1. Okay, it will be staying in the access state until period is 1, and then after period is 1, then the transfer takes place, and again it will go into the setup state. For example, after the completion of these three packets of data, there are no more packets of data, right? So that means period is 1, that means slave is ready to accept, but there are no more data. So that is why it is going to its ideal state. That means the work is done, the transfer of data is done, no more packets to send the data. So finally it will go to the ideal state. Okay, so this is how the working of the this is how you will be transferring the data in APB bus. Okay, through APB bus, how you will be transferring data? You will be transferring it in this way. Okay, so now the same explanation, okay, we will be doing it by using the timing diagrams. Okay, so as we already told you that the transfer will be in either write or read states. Okay, so based on, in just now we have discussed, based on the periodic signal, either the master will be in waiting state or it will be in no waiting. That means if period equal to 1, the master no need to wait na, so that is why it will be no waiting state. So we will be discussing that, like with wait states how it is happening and without wait state how it is going to happen. So first, clock. As you already know, clock should be in positive. During the positive edge of the clock cycle only the transfer takes place. Now, as I already told you, in the initial clock cycle, like in the first clock cycle, it will be the ideal state. So ideal state, so everything will be 0. That's it. No, nothing is going to happen here. It is just in a 0 state. We can say that. Now then, coming to second clock cycle, which will be setup. Okay. So in the setup state, what is going to happen? So the select will be 1. That means slave is selected. Since slave is selected, the address is registered, like P address of that particular slave will be registered. And then the write, here write equal to 1, that means the write transfer is going to happen here, not the read transfer. Okay, so write equal to 1. So these two will be done in this setup clock cycle. No more thing will be done in this clock cycle, these two just. Okay, so along with p select, p write and p address will be activated. Now coming to the access state. So in access state, along with these three, p enable will also be activated. That means p enable will also be equal to 1. So if p ready equal to 1, will the transfer takes place? No, it will be checking for p ready. Okay, so p ready is also 1 here. So that is why, since p enable is 1 and p ready is also 1, there is no need for the master to wait. So that is why it is sending the data. So this data will be written into this particular address. That means into the address 1, data 1 is going to write. We are going to write data 1 into address 1. Okay, so in this way, if there are any other packets of data, then again the same process takes place. Okay, then again it will be going for that particular address will be registered and that particular slave is selected, and based on whether you want to read into that data, write into that data, write will be selected and everything will be happening similarly. Okay, so this is how the write transfer is happening without any wait state. Okay, now similarly for read also, if you see here for read also, this is ideal state where no transfer takes place, and this is my setup and access. If you see here in setup, again address, if you, yes, this is only the change. So write is 0. Slave is selected, address is registered, but write is 0. So write is 0 means read transfer is going to happen. In the access state, enable equal to 1 and period equal to 1. So the data is being read from the slave. That means the address 1 is having the data 1 and this is read by the master. Okay, through PR data, this is read by the master and the remaining things are same. Now, coming to the wait state, let us see this. This is somewhat interesting because in the ideal state everything is fine. I'm not always explaining this because I have already explained this many times. So setup. So in setup, first selecting is done and then the data address is registered and writing. So write is 1. So writing transfer takes place. And in the access state, what will happen? Along with these three, enable is 1. Fine. Now you have to check ready. Ready is 0. That means the slave is not ready to accept. So again it has to be in access state only. Again it will change. In the next process, again access state. Again all things are same. Again the period is 0. So again it has to wait for the next cycle also. And in the next cycle, now period is 1. So here the data transfer take until here no data is transferred. Okay. Only here the transferring of data is being done. Okay, and then this continues only if the period equal to 1 only the transfer data takes place. This is same for read also. And before going into one more concept, here I just want to mention you one important thing. Okay, so during this entire process of waiting period, okay, like if you see here the access state is in 3 clock cycles continuously. That means the master is waiting for 3 clock cycles, 1, 2, 3 clock cycles before transferring the data. Okay, because period is 0. So during this waiting period there shouldn't be any changes within p write, p select, p enable. Okay, if there are any and also in the data, that means during the setup phase or during the access phase you have sent the data as 1011, and during its waiting period if you are going to change it, or if you are going to extend it or something, what happens, there will be the loss of data. Okay, because the data which is present only between this clock period only. Okay, only between this t4 and t5 clock period, what is the data that is present, only that will be transferred. Okay, so that is why the data should be in the same format. Okay, because if you are having one data here and if you want to transfer the data that is present in this clock cycle, but you have changed the data in this clock cycle, then what is the changed data that is present here, only that is transferred. Okay, the previous data won't be transferred. That is why mostly if you see, you shouldn't change anything. Okay, this may cause to error in the data. Okay, so basically this is how error occurs. As I told you, there are many reasons, so this is one of the reason how the error occurs. Now similarly, if anything in this changes or if there is any loss of data here, then the slave will be telling you that there is some error. How it is going to respond? It is going to respond through slave error signal. Okay, if you see here, this is my write transfer. Okay, because p write is 1. This is my read transfer because p write is 0. So among this p write and p read also, here if you see, the slave error is 1 during the after period is 1. That means after periodic 1 transfer takes place. So after transfer is taking place, the slave error is activating. That means there is some loss of data. Okay, in both the signals here, see, that means p slave. Generally you won't include p slave error. If you see here in the previous things also, you didn't include any p slave error. Mostly you will be including this p slave error signal only when you think that you should need to get the response from the slave, whether it is just like an acknowledgement. Okay, after receiving it, it will be sending the acknowledgement that it have received it, or else like that. Okay, so basically whenever you need any acknowledgement while transferring your data, then you will be including your please slave error. Okay, so this is about the APB protocol.